Alright guys, we're looking at target 4.5, master learning objective. I can find the probability of mutually exclusive and overlapping events by adding probabilities. So yesterday we looked at independent and dependent events with multiplying, and now we're looking at mutually exclusive and overlapping with adding, so it's a different operation. Okay. So mutually exclusive events are events that cannot happen at the same time. For example, if I had a die, right, a six-sided die, I could say rolling a 2 or rolling a 5. Right? My die can't show both a 2 and a 5 at the same time. Okay, so basically the and doesn't exist. There's no 2 and 5. The formula for mutually exclusive is the probability of A or B equals the probability of A plus the probability of B. Okay, so again, our keyword here is or, and or tells us to add. So yesterday, right, we had the word and tells us to multiply, or tells us to add. Overlapping events they can happen at the same time. For example, rolling an even, that should be or a number less than 3, right? Well, if you think about it, if I roll a 2, 2 is even and it's also less than 3. So both of those things are happening at the same time. Okay, and again, that means there is an and. So therefore, for our formula, it's a little different. The probability of A or B for overlapping events is the probability of A plus the probability of B minus the probability of A and B. Okay. So, or we still have addition. This one just also has a subtraction. Okay. So when we're finding the probabilities, we need to decide if these things are overlapping or mutually exclusive. Overlapping is also sometimes called inclusive, which is what I wrote here, I guess. Ooh. So looking at number 1, a spinner has an equal chance. Oh gosh, sorry guys. I don't know why this is doing weird things. Okay, a spinner has an equal chance of landing on 8 of its numbered regions. After spinning, it lands on 3 or 6. Okay, so if I think about it, my spinner can't land on 3 or 6 at the same time, right? So this is mutually exclusive. So the probability of 3 or 6 equals, well, the probability of 3, it has 8 sections, right? So there's one section numbered 3 out of 8 sections. The probability of 6, same thing. There's 1 6 out of 8 sections. 1/8 plus 1/8. With adding, we only add the top as long as the numerator or the denominator is the same, right? So that's 2/8, which is 1/4. Okay? We've looked at mutually exclusive already, right? We've seen this a lot. Like I can pull out 2 of the sections out of the 8 sections that work. So you can still just kind of think of 2 of the sections out of 8 fit this. Number 2, a bag contains 6 yellow jerseys, numbered 1 to 6. The bag also contains 4 purple jerseys, numbered 1 to 4. You randomly pick a jersey. It is purple or has an even number. Well, if I look here, right, I have purple jerseys that are numbered 1 to 4. So that means there are even purple that exist. So this is overlapping, right? I can have both of I can pick up one jersey and have it be both of those things, okay? So the probability of purple or even equals, well, the probability of purple is, there are 4 purple jerseys and 6 yellow jerseys, so that's 4 out of 10. The probability of even, well, I have 2, 4, and 6, and 2 and 4 here. So in total, I have 5 out of 10. For my and probability, right, which are my ones that are purple and even? Just these 2, the purple one labeled 2 on the purple one labeled 4 are my purple jerseys that are labeled even. So minus 2 out of 10. So 4 plus 5 is 9, minus 2 is 7 out of 10. Right? The other way to think about this, so that's using the formula, is just kind of laying them all out. So I'm going to use the actual colors. Here are my, we'll pretend those numbers represent my yellow jerseys. And here's my purple jerseys. I'm going to circle every jersey that's purple or even, right? Well, this one's even, this one's even, this one's even. This one's purple, purple and even, purple and even, purple and even. Okay, look. 1, 2, 3, 4, 5, 6, 7 out of 10. Okay, so if you can draw the situation, which you can't always, but it makes it easier sometimes. Number 3, a magazine contains 12 pages. You open to a random page. The page number is 8 or 10. For this one, right, I cannot be 8 and 10 at the same time. Right, one page can't be page 8 and page 10. So this is exclusive. Probability of 8 or 10. Sorry, 10. Well, there's one page 8 out of the 12 pages and one page 10 out of the 12 pages, which is 2 out of 12. 1 out of 6. Number 4, a basket contains 3 apples, 3 peaches, and 4 pears. You randomly select a piece of fruit. It's an apple or a peach, right? So one fruit can't be both an apple and a peach, so this is exclusive. So the probability of apple or peach equals, well, there's 3 apples out of 3 plus 3 is 6 plus 4 is 10. So there's 3 apples out of 10. And the probability of a peach, there's also 3 peaches out of 10, which is 6 out of 10, just 3/5. All right, looking at our next page. In your science class, there are 3 boys with glasses, 5 boys without glasses, 7 girls with glasses, and 9 girls without glasses. What is the probability of choosing a boy or a person with glasses? Okay. So, probably a boy or glasses. Well, I need to first start with boy. If I look at my total, I have 3 plus 5 is 8, plus 7 is 15, plus 9 is 24. So I'll throw that up here. So the probability of boy, how many boys do I have? Well, I have 3 boys, sorry, blue, 3 boys here, 5 boys here. So the probability of boy is there's 8 out of 24 boys. Plus the probability of glasses. Well, these 3 boys have glasses, and these 7 girls have glasses. So there's 10 people with glasses out of the 24. Minus our and, right? So I need boys and glasses. And the reason we're subtracting is whatever you have twice, right? I both underlined and circled 3 boys with glasses. That's the thing that's the and. And the reason we have to subtract it is because we counted it twice. Which equals, well, 8 plus 10 is 18, minus 3 is 15. Or 24. Both of those are divisible by 3, which is 5/8. Okay. Again, the other way to think about this problem is go through your numbers and think about which ones fit either of these things. Boys with glasses. That fits both of them. So there's this 3, right? Boys without glasses. Well, they're still boys. They fit at least one of the things. 7 girls with glasses. They have glasses. 9 girls without glasses. That one doesn't fit at all. So 3 plus 5 is 8, plus 7 is 15. Okay? So there's always kind of 2 ways to count up these problems. Number 6 is a little different because it doesn't break it down for me. This is just percentages. So I survey 100 people, 72% have been to Disney World, 58% have been to Disneyland, and 37% have been to both. So the probability of world or land, we'll have to do the probability of Disney World first. So 72% have been to Disney World. So I'm going to add 0.72, right? Because it's changing it to a decimal. Plus 58% have been to Disneyland, so plus 0.58. And then we have to do minus the both, right? These things can happen at the same time. And I probably could do that without a calculator, but 0.72 plus 0.5 minus 93. So 93% have been to either one or at least one or the other. All right, and that is it.